So today we'll keep solving our Math GRE9768 form. Okay, so 11. For real numbers, the expression x plus y plus x minus y divided by 2 is equal to. Okay, so this is simple. Suppose x larger than y, then the expression is equal to x plus y plus x minus y divided by 2. So it's x, and if you change it y, if y is larger than x, then the answer should be y. So basically this is just maxed x, y. So the answer is A. Okay, 12. Let be a non-empty bounded set of real numbers, and B the least upper bound if B is not a member of B, which you found is necessarily true. So usually in SGR, if somebody asks you about which one is necessarily true, then first you come up with some examples, and then you try to use examples to rule out some possibilities, and the rest you try to prove it. Okay, so this is the technique. So what I like to use is I can let B to be x larger than 0. Let me see, to be x, whether x larger than 0, and second is x squared smaller than 2, and the third is x belong to a rational. This is the usual I like to take. A usual set I like to take. So basically the least upper bound, you guys all know is the square root of 2, but square root of 2 is not in B. Okay, so the first one is B is closed. No, right? Because now what I take is this one to square root of 2, and attack all the rational here. So A is B is closed. It's not true. The second is B is not open. In this case, B is not open. But how about suppose we take B equals to open interval 0, 1. Then the least bound is 1, which is open. So B is open, and 1 does not belong to B. So B is not correct. C, B is the limit point of B. This is the definition of the least upper bound, because this is the least upper bound. So you can try to find a sequence to approach it. So C should be correct. And the D, the sequence of no sequence in B converge to small b. This is wrong in this case, right? I can choose B to be 1 minus 1 over n. So there is a sequence converge to small b, which is 1. E, there is an open interval containing B, but contain no points of B. In this case, suppose we use this as a counter example. We have 0 to 1 and open interval. So what it says that he can find the open intervals cover 1, but not but has no contain no points of B, and this is impossible because this is B equals to, and this B equals to 1. Once I plotted any small open interval, then it will intersect with the open interval 0, 1. So E is also false. So if we delete all the possibilities, the answer is C. Okay, 13. Drawer contains 2 blue, 4 red, and 2 yellow socks. And if if two socks are randomly selected from the drawer, and what is the probability that will be the same color? This is also simple. That total we have 8 socks. So how many? So probabilities we take. Okay, maybe in USA people like to use this notation. Choose A from 2. Choose 2 from A. And the only possibility is that 2 of red are blue, or 2 of them are red, or 2 of them are yellow. So this is 1 plus 1 plus, this is 6 over 28. So the answer is 4 divided by 2 divided by 7. 2 divided by 7. So the answer is A. Okay, so 14, R be a set of real numbers and F G a function from the naked. So their statement say that for any S exist R such that if f of larger than 0, then g of s larger than 0. And we need to do the negation of this statement. So everybody knows about negation. So every time you see for all s, then this is exist s. There exists r, you change it to for all r. Such that is still the same, right? If f of r larger than 0, then the result fails, right? G of s less or equal to 0. So this is just the standard decay, a standard logic. So what is the answer? The answer should be there exists s, and for each r. So it looks like C is the only answer, because there exists r, it exists s, and for all r. So there exists an s in R such that for each r. Right? So 14 is C. Okay, here comes the interesting problem. Is 15. Say that the G is continuous function defined on open interval AB, such that for all this, then G is okay. So first one is G is unbounded. Second one is non-constant. Third one is non-negative. Fourth one is strictly increasing. E is a polynomial function of degree 1. Okay, so suppose this is A, this is B. Okay, and this is A, and this is y equals to x. Okay, so it looks like the function at the open interval should look like this, or probably this, but it must less than this one, this y equals to x. So it looks like it cannot be a constant function. Okay, so suppose you plot the diagram, you plot this graph carefully, then you can see the B is the answer. Okay, but how about we start from we do case by case. Okay, so the first statement, A, is an unbounded function. Now this is impossible. Remember that G is continuous, and the G of x is less than A to x. That means that G of x is less than B, right? Because the maximum in this open interval is B. So G is bounded. And C, non-negative function. Since I only plot this, right? Suppose you plot A to be -1, B to be -3. What I'm talking about, 3, -1, then right, then you can plot the function like this. then this still can be negative. And the D set is strictly decreasing. You can plot this, right? Then this is not this is not strictly decreasing, and it's also not strictly increasing. So basically, it can remain constant for some while, but it cannot all be constant. And E is a polynomial function of degree 1. That's definitely wrong. Alright, this is not a polynomial function. Right, so the answer is B. The answer is B. Okay, so 16 say that for what integer m is a vector 1, 2, 1, 2, and 5 a linear combination of vector z 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, 2, 0. Okay, so 1, 2, and 5, 0, 1, 1, 1, or 0, 0, 0, 1, 1, 1, 2, 0. If m is a linear combination of the rest of 3, then determinant is 0. Right, this is definitely correct. Okay, so we can solve it. The good thing is there is a row which contains the last part. So basically, this determinant is 0, implies that because only this is remaining, so implies that this and this determinant is 0. Okay, determinant of this matrix is 0. And you can solve m easy. Let me see how to solve it. We just direct compute. So this is 1, 1, 1, 2 minus 2, 0, 1, 1, 2 plus m 0, 1, 1, 1. This is 1 times 2 minus 1 plus minus m. Where's m? m is 3. Right, so this tells me that m is 3 from this equation. And fortunately, there is an answer. So the answer is D, 3 only. 3 only. Okay, 17. Okay, I let you guys think about 17 for a while. Because the question is somewhat long. Okay, basically delta is the first increment, and the delta square is the second increment. So it tells you partial information about the increment, and ask you about how do you find f of 4. So this is a simple question. Let me show you how to solve it. Okay, so this is f2, right? This is f2. So basically f2 is f1 plus delta f1. So this is minus 1 plus 4 is 5. Is 3, right? So similarly, 3 plus minus 2 is 1. And how about this? This is delta f3, right? Delta f3 is what? Is delta f of 2 plus delta square f of 2. So this is 6. And the delta f of 2 is minus 2. So minus 2 plus 6 is 4. So this is f of 4. So f of 4 is f of 3 plus delta f of 3. So it's 1 plus 4. This is 5. This is 5. So the answer is E. The answer is E. Right? It's trivial. Basically trivial. Okay, so 18. Okay, so let me. Oh, not too good. Oh yeah, see, it's very good plot. C, and I plot another circle, and I plot another circle which is here. Oh, not good. Right, so this is very closer to the graph, hopefully. And it tells you that the center has innermost radius r and outer radius 1. And r increase the circle O contact the remaining tangent to the inner circle if AR is area of annulus. So this is annulus. And the small AR is the area of the circle region with the center O. What is a circle area region of the circular region with center O? I hope I understand this. It should be this. And ask about the red divided by blue, and when you take limit to be 1 minus. Okay, so let me compute. So the red is just pi 1 minus r squared, and the blue is, I should use blue, right? Blue is so this radius is 1 minus r, so pi 1 minus r squared. So r divided by blue is 1 minus r, 1 plus r, 1 minus r, 1 minus r. Cancel this, and use the limit r go to 1 minus is 1 plus r go to 1 minus r, so it's infinity. Okay, and it's plus infinity. So the answer is E. Okay, 19. Because I don't want to draw a table, so maybe a good way is I just copy the table and teach you guys which of our multiplication tables for groups with 4 elements. Okay, so the common sense is that if G is a group, then for any A in G, then what is AG? So AG means that any group element I times A from left hand side. So what is AG? Okay, I claim AG must be G as a set. Okay, so this is simple that there's no way that two of AX AY will be the same. Otherwise, the X will equal to Y, since there will be inverse of A. So that means that as a set, AG must be G. So that means for each row, the result must just a permutation of A, B, C, D. Okay. So the first one is A, B, C, D, B, C, D, A, C, D, A, B, D, A, B, C. So it looks okay, but we are not clear whether it violates other rules. But we just say, oh, it looks okay. But is it A, B, C, D, B, A, D, C, C, D, A, or this is not okay? This is also a C, D, C, D. Okay. Okay. So it looks like the only remaining is this one. But whether we can guarantee that there must be a group looks like this. Okay, so you can try the Z4. So basically this is 0, 1, 2, 3, 0, 1, 2, 3, because we know that there are only 2 different kind of groups of order 4. Okay, so 0, 1, 2. In addition, so this is 0, 1, 2, 3, 1, 2, 3. This is 2, 3, 0, 3, 4. 4 is 0, right? 0, 1, 2. So this 3, A, 0, B, and C. Yeah, so you can see this table match this table. So this group basically is Z, abelian group, Sigley group Z4. So only the first one is a group. So we choose B. We choose B. That's it. Right. Okay, so here comes our final 20 question. Okay, so 20. Which of the following statements are true for every function f defined on set satisfied f of x divided by x limit x go to 0 is a real number and f of 0 is 0. Okay. So this problem also simple. So let me show you how to do this. Okay, so the first one says that f is differentiable at 0. This is true, and the reason is that this is a definition for the x equals 0 derivative, and then basically f of 0 is 0. So there's no this term, and then it already tell you that limit x to 0 f of x divided by x is a real number L. So this is L. Okay, and the second say L is not L is 0. This is nonsense, right? So counter example is that f of x is just x, right? So L is 1. F of x divided by x, which is 1, x go to 0, which is 1, right? So this is false. And the third one, the limit x go to 0 f of x 0. This is okay because we know that 0. We know that f prime of 0 exists. So that means f is continuous at x equals 0. So when limit x approach to 0, then limit f of x must be 0. So the answer is the first one and the third one. So we choose D. Okay, so congratulations, we solved other 10 problems. And next time we'll keep solve the GRE subject math, and hope to see you guys later. And by the way, be sure to subscribe to my channel.